All right, hello. This is going to be the first time I've streamed in a long time, so there is definitely a few issues and things, like Twitch is not working good for some reason, but I figured that out after the next stream. So hello, if you're new watching this, my name is Stu. I am a principal engineer based here in London, and I decided I wanted to build my own AI agent. So I'm going to walk through the entire process of doing that live on stream over the course of the next couple of weeks. We're going to touch everything from the agent itself all the way down to the underlying operating system, and there'll be a few reasons and stuff why we do that. So as this is the first stream in a while, probably what I'll do for this stream is just walk through kind of my thought process of what I'm thinking, why I'm thinking it, and then we can go from there. Okay, so one of the things we want to first take a look at is like, why do I want to build an AI agent in the first place? Like, there are plenty of other projects I can go and code away on, but why specifically an AI agent? And the answer is quite simple, really. The first few agents that I started to take a look at, such as OpenClaw, Hermes, and even more Web3 traditional one, Eliza, they all kind of suffer from the same problem in that you need to install absolutely everything inside of there, and that to me poses a big risk if I was going to go and do stuff. So it relies you on installing CLIs and all these random packages, and with all the kind of supply chain attacks that are happening, it makes me really nervous that some of these projects are in TypeScript, and how am I going to really trust it? Because we're seeing things like people going through on X and hosting their agents, and then what we're seeing with that afterwards is people are exposing their whole environment files and stuff like this. And I just think generally there is a better way, surely, of doing it. So let's just get a bit of drawing going here so we can go through what it is I'm thinking. So if you think about like what we need for our agent, so we obviously need some models, and I'll go through kind of what I'm thinking about that in a minute. We will need some MCPs as well to do things. We will need potentially some skills as well. One important thing is we're going to need identity. And I'm not currently aware of any standards that do agentic identity. So if you are aware of any standards, please let me know. We're going to come up with an approach for that, which starts off at the operating system level. So I'll go through that in a bit as well. So if we think about like kind of how we're going to structure this, if this is our agent, make the text a bit bigger for you guys. If this is our agent, then the way I want to design this is going to be in a couple of stages. So I want the agent to obviously live on the operating system, but the key relationship here is that the agent does not trust the operating system. It can trust that underlying hardware underneath, but it can't trust the operating system itself. And there's special use cases for that, such as defense and medicine and a few other bits and pieces, even some financial services, especially in the UK where it's all regulated. Then yeah, there's a few things in here that we potentially need to not trust. So we've got that. We're also gonna do an MCP gateway implementation, because what I want to happen is I don't want my agent to be able to see like everything. I want every interaction that it uses to be logged, So we'll have some kind of auditing service down here as well. There's more reasons for that that I'll go to in a second as well. And the last piece that we'll probably build out over the course of a couple of weeks is the control plane as well. So the control plane deploys agents. Actually, it's more like here. So we're going to use our control plane to deploy agents onto the operating system, and then we'll use some stuff on the operating system to provide the agent some identity, and then that will kind of go back to the gateway, and there'll also be a kind of register loop. This will eventually all make sense, I promise you. Just getting it all out so I can talk about it. So that's kind of like the base of what we're going to do. Not only is the NCP gateway going to also audit, but we are also going to have it so that the agents audit themselves as well. So everything that the agent does is going to be auditable, and we're also going to prevent the agent from doing anything that's not part of an approved plan. So there'll be a kind of this multi-stage process of starting off with like a plan, as if you're going to put like Claude in a plan mode or something like that. And once the user then agrees on that plan, then we're going to create essentially a state machine to say, you know, the agent can only do this, 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 and this, and if it's not in this, and then it can't do it. And that fits into something nicely called the EU AI Act, because we've got all this auditing in there, we're restricting it, which is a lot of stuff that current agents don't really do. They can kind of do anything. So yeah, how it's going to work really from the user's perspective, if I think about it from that perspective. And they're going to talk to the control plane and say, hey, I want a new agent, and then that's going to select one of the available operating systems that we have, or hosts that we have, and it's going to say to that operating system, hey, can you deploy this agent for me? And it's going to go, yep, that's absolutely fine, here's the agent. Once that's done, the agent's going to register itself back to the control plane and say, hey, I'm up and running now, all good to kind of start receiving instructions. So almost a little bit like how kind of Kubernetes schedulers and stuff work in that regard, but I didn't want to deploy full like Kubernetes fleet to manage all this stuff, because it can be quite overkill. And this is a learning project. It might go somewhere, it might not. Who knows? So yeah, I think it's probably time I expanded more into like, what do I mean by does not trust the operating system? So on AMD and Intel processors, some of the top spec machines can have, or they have the ability to essentially encrypt parts of the RAM. I think on Intel it's called TDX. So I'll just use that as an example because it's the easy one to remember. So we use something called Intel TDX, and then what that basically does is it says that nothing can get to that piece of memory. So we know that Agent A will never ever be able to access Agent B, no matter what the compromise is. And the way that it does that is everything runs through the CPU, and then we as consumers of that get a channel, which is, I can't remember the exact name, but it's something like Sev Guest or something like, I think that might be the AMD version of it, but it's basically a channel that you can talk to on Linux to go and get the attestation from the CPU itself to say, like, is this genuine hardware? What's its ID and all that kind of stuff. And so we're going to leverage that ability to basically make sure that our agents are completely encrypted in kind of the memory space, and that we know it's running on that hardware. And then what we'll do is we'll send that attestation back to the control plane to register it with all of its cryptographic proof, and then that again will feed back into our auditing subsystem. As part of that deployment process, and this is probably a key part on how that registration step's going to flow, is as the control plane is basically saying deploy this agent, is going to do so with a token. And that token is going to be bound to the identity of that machine. And that will feed it to that agent, and that agent in return returns it back. So what you'll end up getting back on this control plane is you'll get a message that's something like, you'll get the token, say, hey, or it'll be like, ABC123 will be like, hey, whatever. And then it'll provide a signature. And the signature will be a signed version of that token, or something else that we can consider later. So it could be a nonce, it could be basically anything else. But this will be a SHA-256 hash or something. And what we'll be able to do is we'll be able to take that hash and we'll be able to apply some crypto stuff and basically get the public key of that, and then we know, so the agent's going to send this part. The control plane as well will actually know I've bound my mouse button to something, and it doesn't move that. Cool. What else am I do? So the control plane will know essentially, let's say token ABC123 belongs to tenant 123. It's on agent. What's agent ID? It's, I don't know, my first agent. And then it will also know things like what is the soul meant to be, and all the traditional agent stuff there. All right. And then essentially that whole registration loop that we've got here basically then says that key pair that this agent has is going to be bound to this guy, and we know that it's going to be bound because we supply the token through from the control plane through to the OS back into the agent. The agent then signs that message and then registers it back onto the control plane. And because we can apply some fancy crypto stuff, we can get the public key out of it, and then we know that this agent was used with this public key, and then that will link up to absolutely everything in the auditing. So the auditing will have records like so it'll have like the tenant field, it'll have the agent ID, and it'll have the public key that's used, and anything else like timestamp, payload, etc. And that's kind of when what's going to be stored in auditing. So it's quite an ambitious project, but this is all for fun. It's all vibe coding. Could be fun to go through and do. So where I'm at kind of today is I've got a shell of an agent, and if you want to have a look exactly how far it's gone, you can go to GitHub, look at my 5TU, and then it is a project called Notar. It should be public, and you'll be able to see absolutely everything that I've got on there today. So it's a project that's written in Go. All that's there today is a scaffolded Go image. It's literally got nothing in it. We will be doing everything from scratch on stream. And it's, if I go and take a look at the workflow itself, for releasing it, we do a whole build sign, and so it's got things like cosign on there. So we have that whole high trust, because everything that we're doing on this agent is going to be completely high trust, or kind of zero trust, if you, for lack of a better phrase. So it can be used in literally any environment. And yeah, it's got all that kind of stuff set up. So that's kind of all scaffolded out right now. The other bit that I've done and kind of been working on in the background is I've been starting off on the operating system now. And there's a reason why I wanted to start off on that kind of level. And it's basically because I was looking at like, right, if I was going to do this, which kind of operating system stuff would I want to run on? Would I want to do it on like Fedora, or would I want to do it on like kind of an Alpine Linux, or could I get away with something like Ubuntu or something like that? And I came to the kind of conclusion that if my whole principle is I don't trust anything, then I shouldn't, in theory, have any shells or anything like that on there. So if I'm going to draw out like kind of what's in my operating system so far, so if you imagine this is the host machine. Inside of it, I'm using NixOS under the hood to generate the host operating system. This is a very, very custom kernel build, and it's got only the specific things that are required to essentially bootstrap things like the trusted channels on the CPU. It's got basic KVM support, so we can actually like type stuff, but it doesn't have a shell, it doesn't have package managers. The whole ISO is currently 550 meg, I think it is. So I've been working on that the last couple of days. I thought about streaming it, but to be honest, it was much me playing around and not knowing what I'm doing. So yeah, it's just kind of, that host layer is very, very slim. In fact, it doesn't even have systemd on there or anything like that. So once that host kind of bootstraps, it then inits, I've got a host init function, which essentially is my PID1. So if you're not sure what PID1 is, it's the first process that the operating system loads. And I've overwritten that because it's usually a systemd one, and I've got a very, very lightweight version on there. You know what, I'm going to draw out the CPU and stuff as well. So imagine that's our CPU. This will become clear in a second. So what this host process effectively does is it allows me to generate new agents in a containerized way, and I have a small little process that does that as well. So I've got something that I've called Rico, which is just the OCI standard runtime, just reversed. So it's OCI runtime, flipped it around because I needed a name to call it something, and OCI runtime was boring. But basically that OCI runtime, it then goes and sets up these agents. And then that in itself has a guest OS, which is a even slimmer version of the host OS that we've got above. and that has even less functionality in there. What Rico does is it helps set up some virtual machine management stuff and C groups. It'll help set up some networking and different bits and pieces. Just imagine that, yeah, duplicated across. Yeah, so it does a few things like that. It does a few things with the file system, and again, I've got the same setup where I got a guest in it, and that again is PID1. Again, super slim, completely untrusted boundaries and stuff like that. So we don't have any system MD. We're super lightweight, and in theory, this should start up really, really quickly. I'm just in the process of actually testing the ISO and stuff like that. So hopefully in the next couple of days, I'll be able to show that on stream as well. Yeah, once that's all kind of set up, then it runs the container itself. So this is essentially a container. In this case, that's going to be my agent container, but the structure is there so that it could, in theory, run any container. So I think the best way to kind of think about this is this guest OS stuff is essentially what something like Firecracker does, in a really, really similar kind of way. And then this kind of hosty type stuff is going to be essentially what like kind of like Ubuntu or something like that would normally be. The other part of this is actually like I'm just going to term it API for a second. This is essentially a control API for this host. I haven't decided exactly how it's going to look yet, but what this will essentially do is it will talk to Rico, which is the container runtime that we've got. And what it will do is set up kind of tenant isolation. So we'll get a different VLAN per tenant. We will get kind of all the workloads and stuff like that. So if I go back up to my other image where this control plane here says deploy an agent and here's a token, it's going to be talking to this API, and that API will be on a known port for every single box. Then we'll set up things like C groups, net namespace, and all that kind of stuff. So the other interesting thing that happens kind of during this setup process, and I can't remember exactly where it happens. I think it's up here. But essentially what happens is we talk to the CPU on that channel that I mentioned earlier. So let's say it's dev sev guest, that's the one. So we're looking to talk to that kind of dev sev guest. And then what happens in that is we basically can supply a piece of data to the CPU, and then we get back a report from the CPU to say, this is genuine hardware. And here, like, I've signed the key, and that's something that's not even in software, that's something that's actually physically on the CPU itself. And then you run an attestation service across on another node that can go and talk to the AMD and the Intel sites and go and verify all of the signatures from the hardware CPU, and that gives you then confidence that it is genuine, certificates are valid, and all that kind of stuff, which is quite cool. So what we're going to do as part of this setup process, so I believe somewhere either Rico on the guest OS might be in the kit in it. We're going to actually use this to generate an ephemeral key pair that forms our agent identity. So this will, so our ephemeral key pair will have a private part and a public part. And it's essentially going to be the same standard as an Ethereum wallet. So we could, in theory, use this directly as an Ethereum wallet if we wanted to, which opens up a ton of possibilities for the agent. And what we're going to do once we've got this ephemeral key pair established is we're going to expose this as dev/identity. And this will be given to your container here by the guest runtime. We'll do that mapping. So yeah, I think it happens in here, thinking about it. So the guest init process does the communication with the CPU, generates the ephemeral key pair, and then exposes /dev/identity to your container. But crucially, it never exposes the private key, because what we're going to be doing on here is we're going to be having a couple of different methods, kind of like report to get the attestation report. We're also going to have a sign method as well. So you can basically pass in an arbitrary string and it will be able to sign it for you. So your container never gets kind of the private key. It's all encrypted in the memory of the virtual machine, and that's kind of running here, if you want to call it a virtual machine. It's all encrypted in this kind of namespace, process namespace here, which is guaranteed by the CPU. And because of the attestation service, we trust the CPU. Therefore, we can trust the memory, we can trust the key pairs that are generated, and thus any signatures that come from that are also trusted. That's a lot of explanation about how that's kind of all structured, but that's kind of where I'm at the minute. Is I've got the kind of compiling. I've got it in theory doing the process one, and then I haven't actually got that far yet because some issues with Hyper-V. But that's essentially there and working. Guest OS is essentially there and working. Guest init is essentially there. Dev identity channel with the report and sign methods and stuff are essentially there. Rico is there, and initially I thought this was going to be a CLI project, but then I kind of thought about it. I will need it to I will need it as a kind of a CLI, but I will probably use it as a crate inside of the API as well. So the API is written in, or will be written in Rust. Rico is also going to be written in Rust. PID1 here and here is also written in Rust. But when it comes to the agent that we're going to deploy here, that will be written in Go. And the reason why I was going to write it in Go is because there is a project called Bifrost, which I'm just going to go and bring up. I don't know where I see it. Nope, it's not that. Apparently there's loads of things called Bifrost. Yeah, I think it's this one. So this is Bifrost, and basically there's two parts of it. There's an open source part which we'll be using, and there is a enterprise paid version, and we're not going to use that. I think the open source version is going to do exactly what we want to do. What drew me to this project is, I'll actually make this a bit bigger for you guys as well, is basically it looks really, really easy to kind of drag or change these models. So if I go switch between these tabs, then there's kind of like the API surface looks really clean, and it looks generally pretty cool. I'll go and have a look at the docs as well. It's got a gateway, it's got loads of supported providers as well, so I can effectively then power the model portion of my agent with this. So I can go and pick OpenRouter, and then each agent can be configured in a different way. So that will be part of the agent configuration, is to say like, hey, I want to use this provider. So if I wanted to use OpenAI, for example, then we could do this. And there's a few things I need to go and take a look at, but we'll go and take a look at it on stream and go and figure this all out together. Lots of stuff that we can sit here and play with. And it's got routing rules and stuff like that as well, which is really awesome. And I think one of the things that kind of pulled me towards it initially was it's all kind of open source. It's all majority written in Go, which is awesome. And yeah, we can either host this as kind of a gateway or ourselves, and we can apply some auditing and stuff like that. So if we ran this gateway and then we posted in this model here, we could in theory wrap that, attach our auditing, validate our signatures come from the AI, validate that AI could use that model, etc., which is quite cool. So I can either, by the looks of things, I can either do it on the API or direct integration. So that's what we're going to take a look at for that portion of the code when we get around to it. There's a few other things that I wanted to do with this project. I mentioned kind of the MCP gateway here as well. One of the things that is a little confusing when you need to, and how some of the other agents are kind of built these days, is when you add an MCP gateway, you kind of give it everything. It's like, here is the entire MCP, and then the agent can do whatever it wants with that. And that's not always great. Like, you might want a research one. Say like you're researching something using the X API, for example. If you're doing that, then you don't want it to necessarily write your tweets for you. So what I'm probably going to be doing on this MCP gateway, and I'll take a look at what Bifrost has in this regard as well to see if it lines up. But I'll be taking a look at saying like, right, when the agent makes the call to the tools list endpoint, standard MCP tools list, then it will give you back like only the tools that you're allowed access to for that specific agent, and we'll do that based on the kind of identity and stuff like this that we've got down here. So yeah, that's going to be quite cool. And then obviously that's going to feed back into the auditing. Hey, this agent invoked this endpoint. This agent did this. Because we know all of the identity, then it'll all be good. What else was there? There's a few other things that we can potentially do on that MCP gateway, which would be cool as well. So we could introduce like a filtering engine in there as well, where you can write your own policies. So even though you've got an MCP gateway there, you could potentially apply the policy to that that MCP as well. So let's take our tweet example. You might write a policy that says the agent will never be allowed to post between 7 p.m. and 9 p.m. on a Friday. We can do all of that filtering inside of the MCP gateway and order any rejections and all that kind of things from a central point. So yeah, that's kind of where I'm at today. I need to do a bit of research on Bifrost. I need to do a little bit more thinking about like what is the structure of the agent itself. So effectively, I'm just going to have a single agent, and it's going to have a single loop with a single MCP server, which would be the gateway. That gateway will then return all of the tools that the agent is allowed. In terms of local tools, this is something else that I was thinking about as well. Is in your harnesses like Claw Code and OpenClaw and stuff like that, they have things like list in file directories. They use basically things you can do on your local machine. And essentially what I want to happen in the AI agent that I'm building is I want to essentially draw a box here that in effect says anything that's inside of that box is immutable. It can do stuff externally by calling out to a relevant endpoint or API, but it also will be like immutable, so like nothing's going to be local. So in theory, these agents are pretty much just in effect serverless loops that are running, so they should be really light and fast. The memory system is going to be really interesting to kind of work with, especially because we could tear this agent down and spin it up somewhere else, and there's a whole thing that we're going to take a look at there in terms of agentic memory and how different we're going to use different memory store types and all those kind of things. Yeah, essentially I wanted this whole project set up to kind of be there to be immutable. I didn't really want to trust anything, to be honest, not even the host OS. So I wanted cryptography throughout, even on the auditing. I wanted there to be a cryptographic link between, say, this audit entry and the one that's generated after it, so you'll be able to tell with absolute certainty whether the audit log was ever tampered with. And there's a couple of things that we can do with that. We can essentially say this is the first record, this is, and here is its hash, right? So we might apply like ABC123 here, not ABS123. And then on the next row, we could take the hash with the same mechanism plus the hash of the previous one, and then apply the new hash. And that would be a very, very similar kind of output. Or there's something called a Merkle tree, which we could potentially use as well, which basically says, you can prove that, mathematically prove that this did derive from this. So there's a couple of different interesting techniques that we can take a look at here that I think will be quite cool overall in the end. And all of this we're going to be building out, but I think probably the first bit that we're going to be building out is this key generation strategy, because there's two things that we're going to need to be able to do on that key generation strategy. So if I think about that now, key strategy, we are going to need to check to see whether the identity exists. And remember that dev/identity comes from the operating system boot process here. So it will come from this initialization process. We'll get the dev/identity. But obviously for local development and stuff, we are not going to be getting that agentic identity. So we need a fallback option. We need essentially in memory keeper. And then the other thing that we will need from this is a bit later on, we will need a HTTP client with signature algorithm. So we use a standard kind of HVAC signing where we'll take like the body, we'll take some headers, so say like the URI, the verb, usually like get, put, post, etc. Body hash, verb, timestamp to prevent replays, potentially a nonce as well, so that's a number that's only used once. And we'll combine all of that to generate something like X agentic signal. So again, that'll be like ABC123, and we'll get that from dev identity side. So we'll pass the hash of all of this. We'll make a canonical version. So that basically means just put it in a fixed format that's consistent over time. It's the same input, generate same output, deterministic, and then we can apply the signature on there as well. And if we do that for all of the outbound HTTP requests that we're going to make, so to things like the MTP gateway, to the auditing service, stuff like that, we'll be able to take that signature, we'll be able to reverse out the public key, and then we will be able to assign or look up from the control plane, hey, who owns this public key, and then get details of like the tenant, the agent, etc. So all of that will be, well, that will be pretty cool to work on. So that's probably where we're going to go in the next stream. I'm going to set up that piece first. Trying to think what else is live missing. Yeah, I think that's mostly everything I'm going to initially cover. Actually, writing the agent loop itself is going to be relatively straightforward. There'll be a control set of system instructions. We'll inject the personality from whatever the control plane said is the current soul. Then we'll say like, here are all the tools that you're allowed to have. Here's all the native tools. So we'll have a few like native tools, but there won't be anything to do with the file system. They'll be like, get memory, set memory, etc. And so we'll go through and do all of that. And that's going to be quite a quick and easy loop to write. I'm just going to check what else is on my notes. What else did I have in there? So yeah, I've already covered like the brain that we're going to be putting in, which is Bifrost. We've got the agent loop itself, the tool framework that we're going to be using. Again, that's going to be quite small. Configuration. And observability, persistence. Yeah, I think I'm going to talk about the loop that I had planned. So I'll put that over there. So in a lot of cases, what happens is you write a message. So this is in something like OpenClaw. You write a message, that goes to an LLM, and then LLM invokes tools. Unless you're in some kind of planning mode, then it just goes and invokes tools, gives you a result. I want my engine to be slightly different. You still write a message somewhere. But then the key part is an LLM generates plan. And it will always do this. And then there'll be a human in the loop, and that would be to approve that. Once that has been approved, agent will essentially lock plan, and then will execute. And in between all of those steps will be all the auditing. So we'll like audit, and we'll audit. So we can see here is exactly what the LLM generated for us as the plan. Here is what we actually approved, and here is what we've executed. And what this should give us, especially with things like the EU AI Act, is it will be able to give us complete transparency over, like, if this thing went completely wrong, why did it go wrong? Kind of who approved it, which agent was it on, which machine was it running on, which model did it use, all of those kind of things. So that'll be quite cool. That'll be quite interesting to go through and ride that loop. And we'll go through that more in the next stream. Obviously, all that audits go into that audit section up there. This might all just be one API. I just separated it out logically for now, so it's easy to kind of read. Yeah, I think that's pretty much all I wanted to cover in today's stream, just to kind of kick things off, test the streams. I was a little bit tired after the long weekend and all the heat. But yeah, thanks for those who have come and tuned in. If you have any questions, just drop me a line. I'm pretty much Code with Stu everywhere that you can find me on Twitch, YouTube, X, LinkedIn. I'm happy to answer any questions, and in the next stream we will start coding away on the agent and doing things like key pairs and seeing how that all works under the hood. Yeah, cool. I will see you guys next time. Have a great one.